Stoichiometry, mass to mass. Solving mass to mass problems. In a mass to mass problem, you're given the mass of one substance and asked to find the mass of another substance. To do this, we're going to break it down into 4 steps. The first step is going to be to balance the equation. This equation is essentially a mole ratio of the different species going through the reaction. So once we have a balanced equation, we can then convert the mass that we know of the thing that we know. We can convert that into moles using our molar mass of the substance. The third step then is going to be taking the moles of the thing that we now have and converting it into the moles of the thing we are looking for. We're going to do that by using the mole ratio between those two species given in the balanced chemical equation. Once we have the moles of the substance we're looking for, we can then convert the moles to mass, again using the molar mass of that substance. Pause the video here and see if you can write the balanced chemical equation that's being described in this example question. Hopefully, what you came up with is that we have one molecule of glucose reacting with 6 oxygen molecules, being as this is oxygen gas under normal substance, normal conditions, it should be O2. It'll create CO2 and H2O. In order to get these substances to balance out in the equation here, we need 1 mole of glucose with 6 moles of oxygen to produce 6 moles of carbon dioxide and 6 moles of water. So first step done for us. The second step then is, based on the question here, it's asking for what mass of water is produced, starting with 541 grams of glucose. So we're starting with this substance of glucose here, and we have a certain amount of it, and we want to find out how much water is produced. We can't apply the 1, remember there's 1 mole over here, to 6 ratio to the mass, because this 1 to 6 ratio is not a mass ratio, it's a mole ratio. So we first have to convert to moles before we can do that. So we start off with our mass of glucose, and we use a conversion factor to take, and again, we're taking our molar mass and using it as a conversion factor. The molar mass of glucose should be 180.18 approximately. This will cancel out units of mass and will give us an answer in moles of glucose. So now that we have moles of glucose, we can now convert that into moles of water using the molar ratio from the equation. So we'll take our 0.3336 moles of glucose, we'll apply another different molar ratio to it, conversion factor to it, which is the molar ratio from the balanced chemical equation, which says for every 1 mole of glucose, there's 6 moles of water produced. This will cancel out moles of glucose, and again, make sure you put units on every number, and make sure you label those units so you know when you're talking about glucose and when you're talking about water and what unit it is you're talking about. The units of moles of glucose should cancel out. That's why we use the conversion factor, and that will put us into moles of water. Now that we have moles of water, the question was asking for what is the mass of water. So we have the moles of water. We will then set up our last conversion factor, and again, we put the units first. We know that we're in moles of water, so we have to put moles of water on the bottom so that they cancel out. And we know we want to get to the mass of water, so that goes up top. And then we look at the ratio between those two. 1 mole of water weighs 18.02 grams. So we can use that molar ratio, and we end up with our answer of 36.1 grams of water being produced from the 60.1 grams of glucose. Again, we can see the mole ratio is 1 to 6. The mass ratio is not 1 to 6 because that mole ratio does not apply to masses. You have to first convert 2 moles, then convert from moles of one thing into moles of another thing. Then you can convert back to mass to get that final answer in grams. Alright, let's try it a second time. Here's the question. See if you can write a balanced chemical equation. Pause the video and write it down. Hopefully you ended up with aluminum reacting with iron oxide. It'll take 2 aluminums to react with 1 iron oxide to produce 2 irons and 1 aluminum oxide. The question is saying what mass of aluminum oxides. We're looking for this as our product. is produced when 54 grams of aluminum, so we're starting with the mass of this one, we want to convert to mass of aluminum oxide. Now it says excess, and we know that we don't need to worry about the iron oxide. It's not going to factor into this calculation. There's enough of it. We're just converting from aluminum to aluminum oxide. So, take the balanced equation. First thing is to take the mass of the aluminum, and again, we can't use that 1 to 2 ratio until we're in moles. So we set up our conversion factor that will convert it into moles of aluminum. But again, we don't want to know the moles of aluminum. We want to know from aluminum how much aluminum oxide is going to be produced. So we have to take that moles of aluminum and convert it with a mole ratio conversion factor. So the moles of aluminum cancel out, and we end up with moles of aluminum oxide. And then, when we have our moles of aluminum oxide, we can use our final conversion factor, because the question was not asking for moles of aluminum oxide, it was asking for mass. So we put moles of aluminum oxide on the bottom. We use the molar mass to find out how much 1 mole weighs, or how many grams there are in 1 mole. And then that will give us our final answer, approximately 102 grams of aluminum oxide produced. You can do this a lot faster. If you look at it, essentially, we're starting with our number here. We're applying the first molar ratio, first molar mass ratio, second is the molar ratio, and third is the other molar mass ratio to get to the final answer. We could skip writing this part down twice, and then writing this part, and then using it again and getting the final answer. What we could do is we could just take our 54, apply the first ratio, then the second ratio, then the third ratio, first conversion factor, second conversion factor, third conversion factor, and get our answer. So the more efficient way of doing it would look a little bit like this. So take your first number that you're starting with grams, and we have that grams on the bottom of aluminum, go to moles. We then need to convert, so grams of aluminum cancels out in the first conversion factor. This is our first conversion factor there. That gets us to moles of aluminum. This second conversion factor will take moles of aluminum and cancel it out and put us into moles of aluminum oxide. But we want to be a mass, so we need one more conversion factor that will cancel out moles of aluminum oxide, because it's on the bottom, and end with grams of aluminum oxide as our final answer. If you set it up like this, you use a whole lot less paper. You also don't have to write down the answer each time. You don't have to write it down here, you don't have to write it down here, and then use it again. So there's less copying error, there's less calculation error, there's less rounding involved in doing the answer as well. So overall, a much faster, more efficient way. And your final answer, being as we went in with 54.0 grams, we should end at just 102 grams with only 3 significant digits, because we went in with 3 significant digits. While you're doing the calculation, you might want to keep a bit more, but once you get to your final answer, make sure it's in the proper number of sig.